contents of the slides today, it's a very small slide. I just want to open up your perspective about the idea of open source hardware. So we'll talk about what is open source hardware, what is the difference between open source hardware and open source software. Everyone seems to know about open source software. We're talking about Linux, Android, GNU, and all of that. But not many people are talking about open source hardware. Then we'll talk about the definition of it, and we'll talk about the different layers in it, okay? And then we'll talk about what does it matter for us, people in developing countries, okay? And then we'll say some examples, and in the end, a little incentive, why do we do open source hardware? Okay, next slide, please. طيب. Richard Stallman, I don't know if you know him or not, he's the one who founded the GNU project, the open source license, GNU. This is what he had to say. Basically, I seek no social imperative for free hardware designs like the imperative for free software. Freedom to copy software is an important right because it is easy, no any computer user can do it. Freedom to copy hardware is not as important because copying hardware is hard to do. So basically, Richard Stallman thought that the community should not concentrate on open source hardware. He thought that concentrating on open source hardware is a waste of time because copying hardware is hard to do, whereas copying software is easy to do. Basically, all you need to do is copy and paste, Control-C, Control-V. But nowadays, we see that our world is changing rapidly. We just heard about the last lawsuit between Apple and Samsung, where they sued them for, until now, about $1 billion for copying their hardware. So, idea of copying hardware is becoming an important idea. So, let's see the definition of the open source hardware. Next slide, please. Okay. This is not open source hardware. The idea of open source hardware is basically it's a layers. It's like a 7-layer sandwich. That's why I have this picture here. So idea is we have 7 different things on top of each other. All of these, or at least one of them, can be considered to be open source hardware. So let's see what are the 7 layers quickly. Next slide, please. Okay, the first one is the mechanical design. This is the things you do in AutoCAD or in CAD software, where you do the mechanical design. This can be for anything, not necessarily computers or phones. It can be for machines, anything, okay? And usually, it has a software like a file like this. Then, okay, next slide, please. And this is the first layer. The second layer is where we have the schematics for the circuit. And this schematics is usually done using a schematic software, like basically like Eagle, and like many schematics program, and they give you the output as an image, PDF, PMP, GIF, PNG, and usually it has the name of the parts, but not necessarily the industrial name. And I can say, for example, resistor 20 ohms, for example, okay? But I will not say where is this resistor coming from or what is the price of this. This is just a simple schematic, and this is the second layer. So we have mechanical and then schematics. The third layer comes the parts list, and this is usually a text file saying what parts do we need, how many of them, okay? And what are these parts? This is the third layer, a very simple layer. Next. Fourth layer is the layout diagram, and this is a very important layer. Schematics is not enough to build hardware, because you need to know where should you put the parts. You need to know what is the best arrangement for them, how to decrease heating and all of that. Okay, so this is the layout diagram, and usually there are special software for this, and this is usually like a printout for the printer, because when we print schematics, it prints it like a small printer on special schematics, special schematic layouts. Okay, so this is the fourth layer. Fifth layer is the firmware, and this is the code on the hardware itself. Okay, so for example, if you have an iPhone, the code would be the iOS on it. Or if you have an Android phone, the code would be the Android OS on it, the operating system on it. And this is the firmware, and usually this is distributed as text files, okay? This is the fifth layer. The sixth layer, this is the software layer that talks with this device. For example, if I have the phone like the iPhone, the software, the API would be the iTunes on the Windows that you can talk with it, okay? Or for example, if you have a Samsung phone, the software API would be the Samsung keys, the software that talks with it, and so on. The seventh layer, basically, the seventh layer is any other things we need to communicate with it with these devices. Okay? So all of these together is basically what we call the open hardware layers. And now the question is the following. All of them together, one of them, usually some companies will give you only one of these layers as an open source. Others will give you all of them together. So let's see some examples of this. Next slide, please. Okay, so we have the WRT54GL wireless router, the Cisco router. For example, Cisco would give you the firmware open source for this. Why? Because sometimes you as a buyer, as a user or as a company, would like to change some things in the router. Change some things how the router security goes. Or change some things how the router protocols talk to each other. Okay? So it gives you the possibility that you can change this. If you like to change this, I will give you the firmware, and you can change the code and compile it. But I will not give you the schematics. I will not give you the diagrams. I will not give you the parts list. You cannot build this, but you can change the firmware in it. This is one example. Next example, please. Okay, the next example is the Roomba robot vacuum. I don't know if you know this vacuum. It's a small vacuum. It's very popular in the West. It's a vacuum cleaner, مكنسة كهربائية يعني, that goes around your house and cleans the house by itself. Okay? So it goes to this room, checks it and cleans it until its battery is almost weak. And when the battery goes down, it goes to its charger and charges itself. Okay? So it goes by itself. طبعا الرومبا vacuum robot, لا, go back please, was very popular at first, but one of the problems is that houses in the United States had stairs. So the software in the beginning used to go to the stairs, and the vacuum would just go down the stairs. Okay, and never go back. But then they changed the software and fixed it. But my idea is that they give you the open API interface for this. So if you want to do software that communicates with Roomba to do other things, you're free to do. Okay, so they give you the open API software. Next, please. Okay, so we have the ambient orb. It's like a special meditative light, a light for meditation for them. And for them, they don't allow you to, it's not completely open source, but they give you the schematics, okay? They give you the possibility that you can build their own, okay? So this is another example. Next, please. Right. So, do we need open source software, open source hardware? We don't need it. What is the advantages for our countries? Most advantages for our countries is the knowledge transfer, okay? We don't have to reinvent the wheel, okay? So this is very important. If we get the open source hardware, you don't have to redo all of the steps to build your processor or to memory or Ethernet cable and so on. Other thing is cost reduction of design process. I don't have to spend money on research to know how this thing builds. I can take just this design. Third thing is to explore and encourage innovators. When we have the open source hardware environment, we can tell innovators, listen, build your own open source hardware, publish it with us. Companies can come and take your publications, and maybe they can implement it in the real world. So we can explore and encourage innovators. And basically, we can have a different views. Different views have different advantages. The market has different advantages. The developers have different advantages, and the users have different advantages. Next slide, please. Okay. So what is the advantages to us, local universities? Basically, you have a new source of learning. We can tell students, go to this website or go to this free source package and see how a CPU is built, okay? So this is a new source for learning for them. We can share the development we have. If one university, Qasim University, did some development in one project, it can share it with other universities or other institutes. We can have feedback or support. Sadly, and this is very important, sadly, a lot of our projects are done for 1 semester or 2 semesters, and then they are thrown in the closet, okay? The student graduates, he goes to his job, and he never thinks about it. But if we have it as open source hardware, he can listen afterwards to other students telling him, listen, I saw your project. It has this good and good thing. Or it has this bad and bad thing. Or why did you do that? Or why did you do this? And maybe they can extend it and continue it. Okay? And it can have a source of innovation, as we said. And then we can show the projects of the university. It's a way for publication. How can we know this university is doing these good projects if they are just stored in the closet somehow? Okay? We can have free tools and designs to build upon. And this is a very important problem we have in these, in our universities here, in local universities. Problem is, most students take this same project every semester. They do it from scratch, from A to Z, and then they stop. Most of the projects, I will give you simple examples for computer system. Home automation system. Home automation system, a processor that controls maybe a condition or a thermostat. Or a car robot that goes until it finds a wall and then goes left, okay? Maybe for computer scientists, we have websites for ordering food, okay? In 3-4 years, I've seen maybe 500 of these projects, okay? Now why? Because they don't have anything to build upon. But if this student finishes and then another students continue, maybe he can do something more, okay? So next slide, please. طيب, what is the problems? First of all, we have lack of technical expertise. Sadly, we have people are educated, but we don't have enough technical expertise in the industry in building these things. We have lack of industrial R&D activities. Countries, especially in the Gulf world, especially in Saudis, are spending a lot of money these days to do R&D. But still, compared to the Western countries, it's very little. We need to do more. One of the most important, we have lack, or maybe we can say absolutely no cooperation between the industry and the universities. Okay? And this is important. In the West, senior projects are done this way. A company, maybe like Boeing or like UTC, would come to the university and tell it, I have this project for the students. Can they do this for me? And they would explain it, okay? At the end of the semester, students have gained knowledge, and the company have gained, and the university have gained. They have a good cooperation between all of three, okay? And then we have lack of cooperation between universities. Sadly, universities see themselves as peers that they have to compete against each other, not as peers that they have to help each other out to build these countries, okay? Next slide, please. Some examples of open source hardware we have nowadays. So you can go back for. We have the Open Tech package, which is basically a huge package, 10 CDs. Now they give it out as 5 DVDs with a lot of example. Yeah, I'm sorry, it's not showing the schematics good, but you can use it to design schematics. Next one, please. KCAD is for doing CAD mechanical designing, where to put the parts and the chips and all of that. And next. Also another one for showing the schematics and the pin layouts. Next. GTK Wave for doing simulation for your circuit, seeing how the circuit would do before building it, so you don't waste money on building things and they are not working well. Next. And this is Magic. This is for printing circuit boards. And this is, if you want to print it on a circuit board, you can use the Magic. Open Course is a website dedicated for all of these things, and you can find many things on it. A Radix FFT, a hierarchical, and all of that. Okay. So the last example I will give today is the Arduino layout. And the Arduino, a lot of students, especially in computer engineering, are doing projects based on a small microprocessor or a microcontroller with small chips connected to it, sensors, like a temperature sensor, a sound sensor, or like motors and so on. Problem is, before everyone, we had no standard which processor to use. And usually, the student ended up using the processor that his teacher or her teacher knows about. Maybe that's an old processor. It's not used anymore, okay? So a group of researchers in Italy, they developed what they call this Arduino. They built a system, I will not say a processor or microcontroller, a system that you can take microcontrollers on it with open source designs and with open source software, and you can connect it with other sensors for very cheap. So you have a small computer that you can do a lot of your projects on for $29, $30, and that's it. And everything is open source. So if you need help how to connect this microcontroller with a motor, you'll find it very quickly, because everything is open source. There are a lot of tutorials. And then the program, it started in Italy and it became international. And it is now almost the standard for projects. Instead of people wasting time, what processor should I choose, what parts should I take, they would just go take one of these kits and build upon it. Okay, next one, please. So what is the main objectives of Arduino? It is simple. It takes the messy details of microcontroller programming and wrap it in one package. You get one package. Inexpensive. It's very inexpensive, as I said. Cross-platform. It works in Windows, Mac, Linux, whatever you like. It is clear programming environment. Environment is clear, very simple, RISC architecture. It is open source software and open source hardware. Okay, next slide. This is some example of projects done in Arduino. This is what we call, what was it called? Twitter plant, I think. It's very simple. Now your plants can send you Twitter, okay? So you connect your plant to an Arduino microcontroller and to a sensor that senses when is the soil dry. لما يكون يعني التراب ناشف, okay? فif it senses, طبعا it's connected to the internet using an Ethernet or wireless. فif it senses that يعني this plants need you to water it, it will send you a Twitter to your Twitter account. Please give me water, okay? And if you give it water, it will send you another Twitter. Thank you for watering me, okay? It's a very nice project, but notice now when we have these vast areas in farmland, especially here in Saudi, how we can use these kind of projects to help us in automating things, okay? So this is one example. So in the end, why do we do open source? We started this slide by saying that people like Richard Stallman thought that open source hardware is not important. Okay? Then we saw a lot of examples and a lot of incentives, especially us here in these countries. Why do we need open source? First of all, you can join a community. Instead of working alone, you can see a whole community of people. What are they doing? And you can get a lot of ideas. Then, second thing, what we make will outlast us. What you done, it will not be put in a closet. It will be done on a website. People can discuss it. People can extend it, and you can see it. Okay? I give you an example of this. When in the 1990s, when the MP3 players were very common, but building them was very hard until someone did a project called Tiny Mint. Tiny Mint. المنت عندهم اللي هو النعنع عندهم فيه علبة يعني box of ملبس أو حلاوة لنعنع بحجم size of this box. Okay, he did a project for an MP3 player size of this box, and then he published it basically on the internet, and it became a hit. Millions of people designed the same project because people needed to know how MP3 players were built, and they all went to his design. To become better engineers, as I said, you can see people giving you feedback, telling you where you went wrong or where you went right. And you will always get back more than what you give. This is very important. In the end, you are getting back by giving out education. Okay? This is, I think, the last slide. Next slide, please. This is some credits where I took some of the slides and some of the information. Thanks to them. Finally, next slide. Thank you for your time.